So this is question number 13.8, and the question says ki how long can an electric lamp of 100 watt be kept glowing by fusion of 2.0 kg of deuterium? Take the fusion reaction as 2 deuterium nucleus gives 1 tritium molecule and 1 nucleus neutron plus 3.27 mega electron volt. So that is the reaction. This is the reaction that is given here. Okay, so now let's solve this question, and we are going to solve this question as a explanation for board examination. Now the same way you can write it, this answer also in your examination. So first of all, you have to write the given that section, and in that you have to write the mass that is given for your deuterium, then molar mass of deuterium, then energy per fusion of the reaction what you are getting, then what is the power of the lamp given 100 watt, that is 100 joule per second, means 100 joule of energy is needed per second, or it is utilizing per second. Then Na Avogadro number, and then how we convert mega electron volt into joules, right? Then after that you have to understand that what the question says is a bulb is there, and it takes power of 100 watt, means 100 joules of energy is needed per second for it, right? So if we are able to calculate that how much energy we can generate from 1 kg of deuterium, and in joules, and if we divide that with this power, that is 100 watt, we are going to get that time in second, right? So this is the basic thing that we are going to do in this whole solution, right? So first of all, we have to calculate the number of deuterium, then we can into or multiply that with the reactions energy that we are getting in per reaction, right? So number of molecules of deuterium is 200 gram. You have to take it in gram, kg, 2 kg in 200, 2000 gram, and then divide by 2. So we are going to get the 1000 mole. This 2 is molecular weight. Okay, so given mass by molecular weight, that is 1000 mole, right? Then number of deuterium molecules is, after calculation, we are going to get 6.023 into 10 to the power 26, right? Then we have to also know that we are using two deuterium nucleus for one reaction, right? So we have to keep in mind that how much reaction is happening into the energy we are getting from each reaction, right? So that is going to give the number of what is the amount of energy that we are going to get, right? So it is needed that we first determine that how much reaction is happening, means number of reaction, how many number of reaction is happening, then we can calculate that how much energy is released, total energy, right? So once we calculate the energy total reaction that is happening, and we multiply it with the energy we are releasing with the per reaction, we can definitely going to calculate the total energy, right? So it is easy. So first of all, you have to convert this mega electron volt into joule by multiplying it with 1.6 into 10 to the minus 13, and then you have to multiply it with the number of reactions that is happening here, right? So the total energy that is released you can get, right? And after that, the total energy once you get, you have to just divide it with the power, that is 100 watt, right? That you can also write as 100 joule per second. And after calculating this, you are going to get that the bulb is going to give light for 1.57 into 10 to the power 12 second, right? So this is the time for that the bulb will glow, right? So this is the basic question, and this is your answer time, right?